Today I am going to be starting a small series, I guess, as we like to call it, where I will be doing daily programming. It'll only be an hour per day, but the objective is a couple of things. One, I want to be able to do a commentary while programming, and kind of to take more like generic programming concepts and be able to explain and talk through them as I do these. So here's how it's gonna work. It's 1 hour long, regardless of what I start with. Give me a second, gotta pull this up real quick. So basically, I select a task that I find either interesting or helpful, and since today is going to be the first day of this, I chose something that's going to be very basic, and we're going to move from there. And how it works is I'm using what's called LeetCode, and LeetCode, it just presents you with a ton of like different programming problems, and you have to try to solve them. Language of choice right now is Java, so we're going to be doing it in Java. And we're just going to knock out as many as we can. When I finish one, what I'm going to do is hit this similar questions, and there's a bunch of like similar problems, and we're just going to like expand on what we learned from each step. So this is like very basic. This is called TwoSum. And so first thing to do is to read the problem. Given an array of integers, return indices of the two numbers such that they add up to a specific target. You may assume that each input will have exactly one solution, and you may not use the same element twice. They also give an example. Their target is 9, and they give us two sets of numbers, 2 and 7, 11, 15. And we assume that every two numbers is a set. So then we have to return those indices. So when coming up with a solution, it's a good idea to always write out some pseudocode so you kind of know what direction you're taking. This is a very simple problem, so we can keep the pseudocode pretty light. So in this case, we're going to start by looking at the first two numbers. That's what we would do, right? And we would have to store the numbers in a slot. So what slot we're currently on, or index is what we like to commonly refer to, is a pointer at the current array we are on. And we're looking at the first two numbers. And then we shift the index over. And before we shift the index over, we check if the target is equal to the sum of index plus 1, right? Something like that. So very quickly, I just wrote out some basic ideas for this. So, because this is an array, we're going to have to loop through the whole thing. We may also assume that each input will have exactly one solution. So we don't have to do any like duplicate checking or anything like that. So we'd like to start with the for loop. For loop likes to count up. Start by giving it a variable called I. I is a counter. And we're going to go until while I is less than nums.length. We're going to increment I by 2 each time because we're shifting over by 2. So I now stores what index we're on. We're going to see what the sum is, so we'll store sum in here. And we can get our array references like so. This gets us our sum in Java. So the only thing left to do now is to see if the sum is equal to target. Do this. That's a good size. If sum is equal to target, then we will return it. What are we going to return though? We have to return an array with both of these values in it. So we'll do a new int containing both nums I. Oh, they want the slot numbers actually, which makes it a little easier for us, honestly. We do I and I plus 1. Excuse me, not like this. That looks like good syntax to me. We don't have anything for undefined behaviors, so we're just going to assume that this is going to happen. But it has to always return an int array. So if we do get down here, then don't know what to do. So we'll just return null, because what else are we going to return? So now we'll go ahead and run code. See if there's any issues. What? Why do you want me to sign up? Alright. I won't sign up with the username, but I'll sign up with this because that's easy. I hope it's saved, otherwise we'll have to rewrite it. Well, it's trying. Any day now. I could have written this in my IDE by now. Maybe I will. What happened? I killed it. Oh, we're back. It might actually work. Oh, no. Yes. Alright. Verify your email? Oh my god. Really? Alright, one moment. I did not expect this. What a cruddy way to do things. We're looking good. So I was thinking of changing this, so I think I will real quick. What I wanted to do was make this larger. And lighter. How does that look? A little more. Yeah. Okay. Cool. I think that's good. So we're gonna run code now. See what happens. I put commas instead of semicolons. So when debugging code, it usually tells you, like here, semicolon expected and stuff like that. Anyways. Right. So when initializing arrays, we're not supposed to use a number here. The only reason you would use a number here is if you are not initializing it, you're just providing a blank array with a certain amount of entries in it. You can only do one or the other. So here they have the tests, output expected, so we can just submit it now. Let's see what it says. Next 3 out of bounds for length 3. So it's 324. I expected a so yeah, it's looking for a fourth value in this case, but it can't find it. So we're gonna have to add like a condition here now. So they don't really go into, I don't want that. They don't really go into like detail about like specific edge cases, but I guess that's one of the challenges, right? So the edge case we have to add here is if this number exists, then we can add it to the sum. Otherwise, we don't add to it. And there's a couple ways you could do that. But you have to measure if the nums.length is less than I plus 1. And what that means is, like, if the array was 6 in length, then you're looking to see if 6 is less than, it would be array element 5 in this case. And if it is, then you've got 6 elements. Otherwise, you can just say 0. That way you don't badly reference something like that. Additionally, you can't include this. So I think what's going to happen is this might just exit. Like, you can't return 2 elements, but I think that was part of the original requirements. Oh, I see. Actually, I misinterpreted this problem. It's, you have 2 numbers that you can select from this entire list. 2 of them add up to the number you're looking for, the target. I first thought they were a pair, but they're not a pair. Okay. That kind of invalidates this right here. And the reason is because we have to change our looping algorithm. So we're just going to comment all that out and look again at what we have to do. Here was our original algorithm. What we're going to have to do instead is look at the first element and then all the other subsequent elements. If nothing matches up there, then we move over to the next element and then look for all subsequent elements that way. It's like comparing different possibilities, right? Like, so we're going to have 2 pointers, index 1 and index 2. Pointers for the positions of the array we're looking at. For index 1 shifts over after all other elements in index 2 are checked. So for example, index 1 will start at 0, then increment by 1 after we shift index 2 over. Index 2 shifts over by 1 each iteration, resetting back to index 1 plus 1 every time index 1 shifts over. And then we can do, we can look at the 2 numbers. Go to the sum of index plus index 2. Like that. That would be our new formula. And then we're not shifting index over by 2 anymore. Shift index 1 over by 1. Reset index 2 to index 1 plus 1. Loop ends. The loop will end when index 1 plus 1 is greater than or equal to the array length. So that's our new algorithm we're implementing. So we're still going to do a for loop, but we're going to do another for loop inside the for loop. So we're going to start with, I did call it index 1, right? Well, I wanted to call it index 1. We can use I for short though, index 1, I1. So in I1, we'll start at 0. I1 is less than nums.length. And we're actually going to put -1 here, because once we're at one position before the max length, we need to stop, because there's not going to be any more searching after that. Now we're going to include index 2 here, which will start at index 1 plus 1 for each iteration, that is. And then index 2 is less than nums.length. Index 2 increments by 1 each time. So now we have index 2 incrementing by 1 each time, starting from one position after the first index, while index 1 starts from position 0, increments by 1 each time until one element before the last one. Excellent. So all we have to do now is try to sum up these 2 numbers. And with that out of the way, we can now compare the sums. And if so, we're going to return those 2 indices. Again, if we get down here, we have some like undefined behavior, which hopefully doesn't happen. But if it does, it does. So that is that. So the initial test is still good. Then we're looking at the submit. Let me close all these real quick. So we can see that that we do have a success here. So that is complete. Now, like I said, I want to go ahead and look at similar questions, because similar questions give us a way to take what we talked about and enhance them, basically. But before we continue, we also want to just kind of review what happened here. So, kind of a breakdown real quick. Loops tend to be a little intimidating because the concept of them is a bit foreign. It's like something has to happen over and over and over again to be checked. Iteration, basically. Basically, if we have an array of numbers like this, our objective was to see what combinations of numbers adds up to a certain target. Say the target was 14, right? Then the only possibility was 8 and 6 here. So, in order to get to make an algorithm that would satisfy that, you have to do 2 sets of loops. The reason why I figured that out was because to get through every combination of number or iteration, you have to look at how you would figure out every possible combination. 0 and 1 is one combination, 0, 2 is another, 0, 3 is another, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, right? Those are all possible combinations of numbers. And if you were to try to figure out what combinations are next, you wouldn't say 1 and 0 are a combination. I mean, you could, but you already did that. And addition is, what would you call it? Commutative. Since addition is commutative, you don't have to check again if the opposite flipped version is equal to the target, because it's going to be the same. So then you just start at 1 and 2. You can like forget about 0 at this point. 0 is done. And you can just look at 1 and 2, 1 and 3, 1 and 4, 1 and 5. And you can start to see this pattern emerge. And so once you see this pattern emerge, then you can say, okay, knock out 1. Then we have these combinations of numbers. And by doing this, you'll never ever repeat one combination. And we can keep doing this programmatically. The number of results shrinks as we continue to go on. So we made a loop that kind of simulates that. This first loop says, start a value at 0, keep going until we are 1 before the last number, increment it by 1. So each step of this loop, it'll start here, then it'll go here, then it'll go here, then here, then here, then here, then here, then here, then it's done. And that's exactly what we want. That's the first loop. For the second loop, we have to say, okay, well, not only do we want to increment this by 1 each time, but we also need to check all the numbers leading up after it. So for the second loop, we're going to start at the position of the first index plus 1. So we wanted our second counter to start here, right? That would be our 0 and 1. Boom, so that's done. Then, when you enter a loop in programming, you're stuck in that loop until everything inside of it is resolved. So all of this code is just going to be stuck until we complete all of this code inside. So this code says, okay, increment. So we're going to increment. Boom. Then we check 0 and 2, right? Solved. 3. 0 and 3. So on and so forth. Once it gets to the end, right here, that's what this says. Once it gets to the end, we're now going to move this over by 1. Then we're right here. Then we say, okay, moved it over by 1. Now we're back in here again, line by line, going through the same exact processes. This gets moved over to +1. Then it goes increments by 1 each time. Now, eventually, we can start talking about how it solves for the sum. Every time this cursor moves over by 1, we have a new set of values to check. We have 0 and 4, 0 and 5, 0 and 6, and they all add up to some number. And our goal is to see if does 4 equal 14? No. Does 5 equal 14? No. So on and so forth until we get to 6, 8. Is 14 equal to 14? Yes. So we're adding up these two numbers at these pointers and seeing if they're equal, and if so, returning them. The problem specifically calls for returning the indices, not the numbers themselves. So we're going to say, okay, so return index number 5 and number 7, which is where these two are located. Or excuse me, index 6 and 8, not 5 and 7. It started at 0, so that kind of confused me there. That's a breakdown of that. So we're going to be looking at this now. This is called ThreeSum. Given an array nums of n integers, are there elements a, b, c, and nums such that a plus b plus c equals 0? Find all unique triplets in the array, which gives the sum of 0. So, this is indeed another problem very similar to TwoSum. It's just now we're looking for triplets. So how do we find all the combinations of 3 numbers? Well, kind of the same way, right? Except we would need 3 pointers. So let's say we had this set of numbers here. Again. So we have three pointers now. We can use the same style, I1, I2, and I3. Start I1 at the lowest number. Start I2. I'll call these A, B, and C. Start B at the second number. Start C at the third number. C will increment by 1 until it gets to the end. Right? Then, B moves over by 1. C then moves over by 1 each time until it gets to the end. Then B moves over by 1 again, and so on and so forth. Now, once B gets to 1 before the last, now it's time for A to move over by 1. And once A is moved over by 1, B and C move back, and then it repeats again. And this will give you every combination of 3 numbers to figure out which set of numbers will equal 0. Now notice their solution can be any unique triplets and must not contain duplicates. So on top of all this, we need to make sure that the numbers defined do not contain any duplicates, as in if we find a -1, -1, 2, for example, and then later on we find another one with like 2, -1, -1, that's a duplicate set. They all have the same related numbers. So we have to check for that as well. So that's going to be another side condition. We'll do something similar to TwoSum. But the new part really is making sure there are unique solutions to the set. How do we determine that? Well, you can kind of see here that they're sorted, right? These numbers are sorted a little. So because the numbers are sorted, if we were to, in theory, sort the numbers after we find a set of triplets that works, we can then see if that set of 3 numbers exists in any of the other solutions in the set to determine if indeed it already exists. So, we have to apply a sort. Now, Java has a pretty nice sort when it comes to arrays. Show that real quick. Alright, we're not going to look at sites, we're going to look at Java docs. That's easiest for us. Alright. So if you look at sort here, sorts to specify array in ascending numerical order. So it's going to be ascending from 0 from the lowest to highest, which is what we want. It's a very simple and easy way to sort arrays, and it's provided in the Java library. So that's what we'll be using to take care of that. It's a public static method, which if you see public static, that means it's just available from the class itself. So if I called this is called arrays, so you called arrays.sort, and then your array, it would return an array that was sorted for you. So our strategy here will be to use arrays.sort, and we will sort that array. Sort the array of 3 found numbers that equals 0. Check all elements in the sorted array that already exists. And finally, make sure all elements don't exist per array. So this sounds like a lot of like loops, and it is. Another way to do it would be to use a hash map. What you could do with a hash map is return a string with like all these numbers next to each other, just concatenated back to back, which is another cool way to do it. So could do it a hash map way, could just loop through each number. Honestly, a hash map is faster, just a little more memory intensive. I think it would be cool to do a hash map implementation for this one, so I think we'll go with that. So we know we're going to need a hash map. We can initialize it here. The hash map itself is going to consist of a string pointing to an integer array. So for a hash map, you specify what the key type is going to be, and then you're going to specify what the structure inside that key will be. So this is going to be our solution set. We're going to make it equal to a new instance of this hash map. So we have that prepared for us when we start implementing. Now, notice the result needs to be a list of integers. So this right here, this notation, they want us to use lists, not arrays. So we're going to have to do some data manipulation to get our arrays into lists. Luckily, that's pretty easy. So what we can use for that as strategy is called asList right here. It's actually in the same Java docs. So asList returns a list structure based on what type of values you provide. So you can provide either an array here, that's what the dots are, it's going to expand out the data values, or you can provide individual arguments like so. Either way, it's going to turn it into a list instead. So that's going to be our strategy for returning the actual result. So arrays.asList to aid with providing the final result. So here in the solution set, every time we find a set of values that is equal to 0, boom, we're going to add it into there if it doesn't already exist. We're probably going to make some functions as well to clean this up, but we'll do that when we refactor. We're going to have to do some refactoring because this is going to get a little messy. So let's start with the basics. Let's iterate through all of our numbers. So we're going to create 3 indexes. I'm just going to call them I1, I2, I3, right? We can actually create them inside of the loops ourselves. So we know we're going to need 3 indices that loop through. So I1 is less than nums.length minus 2. So there's our first index, but we're going to continue. This one's going to go up a little further because it's our b value. So b value goes up to 1 before the last. And then finally our third index will go up to the end of the array. Additionally, the starting values will always be 1 of their previous index. So they're never looking at the same values. Okay. So now that we have that set up, we're going to be able to check if the sum of all those three is equal to 0. So we're going to see if the value at nums I1 and the value at nums I2 and the value at nums I3 end up equaling 0. And so if they do, we're now going to add a unique value to the solution set. And how do we make sure it's unique? Well, we're going to generate a string that composes those three numbers together. So we'll start with a string builder, because that makes it easy for us to append all the string together. So a string builder is a way to quickly build together a string that you might need. So once we have our string builder, we will chain some append calls to it. And by doing this, we're building our string. So each of these appends we're going to provide a value for. So we start with nums I1, and then I2, and I3. Oh, but wait, I forgot. We have to sort first. Because if we don't sort, we won't be able to check for uniqueness. So let's make sure we sort first. So we will create a new integer array containing our three numbers. Just those three numbers. Also, I believe this needs to be a primitive data type, so I will refrain from using the Java class for this, and we'll just use a primitive data type like so. I could explain the technical details for why I think we shouldn't use the Java class, integer class, but don't worry about that. We'll talk about that a little later. With this setup, our next step is to actually sort it. So we're just going to call arrays.sort array. Now, looking at the docs here, it looks like it sorts it in place. So, the array to be sorted, it's going to be sorted in place, which means it doesn't return anything. It's just once we call it, the array is going to be shifted in place. Now that our array is sorted, we're actually going to reference that array instead. So we will reference array 0, array value 1, and array index 2. Like that. Then we have to get our final key. So string key will be equal to the string version of this. So now we have a key that represents all of our numbers. It's just all of our numbers appended together. So if it was -1, 0, and 1, it would be a string that literally looked like this. That's what it would look like. And if there were more numbers, it would be like -1, -1, 2, and so on and so forth. Because the way the numbers are sorted, I don't think there would ever be keys that could cause like conflicts. Like, how would you represent the difference between -10 and 1? Well, for one thing, that's only two numbers. You have to have three numbers, right? So there shouldn't be any numbering conflicts as far as I can see. It's just something that we can observe, but realize that it's not really a problem. So now, we're going to see if the solution set contains a key, and we're going to see if it contains this key already. So if it does, then it's not unique. So we only care about if this is not a, or if this is a unique solution, right? So if it doesn't contain a key, great. Add it into our solution set. Solution set.put uses the key, put in our array. Done. Works great so far as we can tell, right? Haven't actually run it yet. But we're not quite done yet, because now we have to return our final result. And we can use arrays.asList to help us with this. We're going to have to iterate through the entire hash map and produce a solution set like this. So in order to iterate through our entire hash map, we're going to need to grab all the keys. And so we can do a for loop with all the keys. Each key is a string. So we're going to be using this is like an iteration type of loop. And it's just shorthand for checking everything in a set. So if we do solution set.keySet, we'll get an iterable collection of keys, and they'll be of type key. So then we can check every single, what we're going to get back is an integer array, right? So we're going to have to append them all to, in this case, a list. So we're going to have to initialize our result list here. So here we have list integer. I believe they want a list of integers. They want a list of integers. Yes. So we will follow suit and make a list of integers. We'll call it the results. And so, once we initialize it, we're going to have to initialize every value inside of it as well. Because for each array position, there's going to be a list of its own. So, for each one of these, first, create the array. So we're going to be doing a list integer of numbers. So this is the internal list. This is what's going to go in each element here. So this is like one element, and here's another element. It's going to be a list. We have to push all three numbers into this new set. And like I said, we can use arrays.asList to assist us with that. So, what we can actually do here, instead of initializing a blank list, we can do arrays.asList. And here we can specify our array, because that is what's required. A list of items to put into it. So because it's a list of integers, it expects integers, and that's what we have. But we don't actually have our integer array yet, so we'll have to grab that first. We'll call this array. So it will be solution set.get, which lets us grab from that specific key, and then that will return our integer array inside of that key. Then inside of this list, we will use that array to turn it into a list. And finally, we need to append that to our results here. So we will do results.add numbers. So we just added a list to our list. So now we'll have a whole bunch of lists. Finally, we have to return the results. And that should be about all of our code, minus possible syntax errors. Incompatible types. Int cannot be converted to integer. Yes. So, this is what I was talking about, related to primitive types versus Java class types. It's kind of annoying that the conversion is not quite that simple, but we have a couple of ways we could solve this. For one, we can make a integer to an int to integer method to make this all happen. So again, we can't just put in our little int array, we're gonna have to convert all of them to integers. So we'll have to make a new integer array first. Call it the we'll call it the integer array. And inside of that, we will initialize a new integer array that is the same size as the array there. And that way we can insert each value into it. So we're going to call this A1, because we're going to have to loop through all the items inside of that array and insert them into the new array. A1 is less than integer array.length. Increase A1 by 1. Just put them all in there. That's all we have to do. A1 will be equal to array A1. Now, this will automatically convert a primitive int into a Java class integer conveniently. So that makes things easy. Then once we get down here, we should be good, because now they're actually the correct type, and they're stored as integers instead of ints, which are the same thing in theory, but yeah. We also have to change this now because we're using integer array. I did forget to make that modification. Alright, so we can see that the sample gave us what we was accepted. So, interestingly enough, it expected it to be in a certain order, and we gave it this. But it looks like it was okay with that. As long as we gave the correct elements in some order, it looks like it's happy with that. That's funny. So time limit exceeded. So how large is this? This is a very, very, very large number. So what is the time limit anyways? I'm curious. Does it tell us? I don't know if it tells us, honestly. Anyways, it's interesting that this doesn't pass this because it's looking for like an efficient solution. So in terms of finding like more efficient solutions, there are a couple of approaches I could imagine that you could come up with for this. For one, you have to find values that sum to 0. So if you're trying to find values that sum to 0, you're always looking for numbers to like balance things out, right? Like looking at this, I did not expect that they would give such a very like crazy amount of data, which is pretty crazy, I would say. What I do want to know is how long it does take. So what we're gonna do now, because we're pretty much at the point where yeah, it works. It's not 100% efficient. I don't care too much about that, but I do care about just playing with it now because we have that capability, and it's kind of fun to see how long it does take, right? How efficient or inefficient something really is, and what we can do about that. I'm just gonna make a new project here. What is this called? ThreeSum. I think getting all the way to the last 2 tests is pretty good. It's not the best, but it's good. Good enough for our standards. We know the algorithm works, and that's what matters the most. This is called solution. I'm actually gonna change it to be called what it's supposed to be, the ThreeSum class, and we'll just throw this in there. Actually, yeah. Just throw it in there as a public function. Initialize all this, and then we will provide a test case where we indeed run that. So this is just how you initialize a main function. And, oh, let me get all my imports in real quick. Okay. So we'll provide our sample data here, which is a really, really large number, or a really large set of numbers. Boom. So we just went ahead and did that. Have to change the format a little bit so it actually matches Java's syntax there. Let's see how large this actually is. I think it'll tell me. Call this the test numbers. Not const. Final, we'll say. I wonder if it'll tell me when I actually put it all in, but I guess we'll find out. So we're gonna call ThreeSum on it. And we're just gonna have it, let's see. We're gonna have to console.log it somehow, but I don't know if we just, not console log, if we just do this, we're just gonna get a huge list of, yeah, we gotta make it static for this. We're just gonna get a huge list of, I think, list integer objects, so we're gonna have to like parse them down or something, but I just want to find out the runtime right now. So find out the runtime. We can do nanotime actually. I actually forget what nanotime measures in. Nanoseconds. I don't know what nanosecond. Let's just do milliseconds because that at least I know. At least I know what milliseconds are. Millis. Runtime. Then we just take the current time again after we're done here. And we do millis minus this. Or, excuse me, that's backwards. Minus millis. And we just write milliseconds here. Let's see how long that takes. Woo! It takes 5.3 seconds. That is a long time, ain't it? So yeah, it's not highly efficient, but this is such a large set of data. Let's be real. There are so many combinations you could get from this. I like that it actually returned the results though. Let's do some text wrapping real quick. This. Boom. You can see just the sheer amount of number combinations that end up equaling 0, which I think was intentional, of course. They wanted it to be this way. So it does take some time though, and so there are likely ways to improve the efficiency of it. However, for the rest of this time I want to talk about actually refactoring all of this now, because as you can see, if somebody were to read this, it looks like a clumped up mess. So the final thing I want to do for ThreeSum, and I think for the remainder of today, is actually to refactor this a little bit so it looks nicer, just to show you how refactoring would begin, right? So in order to refactor, you kind of have to start with the innermost pieces and like work your way out. And as we kind of walked through this, we said, okay, we have certain things we have to accomplish, like we have to sort, and then we have to insert it into a array, then we have to check it with the hash map, then we have to do this, yada yada, right? So we start by looking here. This is a loop to see, to convert an integer array into an int array. So this right here is all one function. And when you find something like this, you gotta refactor it. So this will be int to integer array. So one nice thing about having an IDE is that you can refactor like this and it'll kind of automatically do it for you. So this right here does the conversion. So int to integer array, we provide an input array, we get an output like that. Then we look at this. Now this is checking if the value in the solution set doesn't exist yet. So this is to check if, well, we include the key as well. But yeah, this checks, is there a unique set? Let me see if this is right. We need to supply an array, the solution set itself, and a string builder. I don't think we need the string builder, so let me correct this. When you refactor, you have to be careful not to bleed in other parts. I'm still gonna have to mess with this a little bit, but we'll at least get it refactored first. So, if is unique solution. So what we need to actually do is refactor this part, because this needs to say is unique solution. That way when we look at it, we're like, oh, is it a unique solution? If it is, then yes, convert it to an integer array, put it in the solution set. Now, this in itself can be one thing as well. Insert into solution set. Like so. Because insert into solution set is going to convert to an integer array and then put it in there. So you can already see this part now says if it's a unique solution, insert into the solution set. It's a lot more readable, and we don't care about the code inside of here because, well, if you really cared, you would go looking. But just knowing what this does, you can trust, oh, okay, that's what that does. I don't have to look further into the code. It's self-explanatory. Now we go a little farther up here. Well, what are we doing? We're first creating a new compact array of our selected values. So that's what this is. Select number array values. That's what we're doing there. So we're just taking all those values and storing it in this array and returning a new array. Next, we're going to sort that array. And once we sort that array, we're going to get a key. So this is building a key. Build hash map key. So here we're sorting. Here we're getting our array. Here we're sorting. Here we're building our hash map key. So all of this encompasses let's see. We can condense it further. I'm just trying to think of what we would call this at this point. So this is this is like to set up the ThreeSum. What did I just do? Ambiguous return value. Oh, right. So we're gonna have to figure out what we actually want because we can't have two return values like this. So this is going to be a sorted, get sorted array values, like so. So this takes our indices and returns a sorted array, which also selects a set of numbers, like so. And so we have that, we have our key, we check if it's a unique solution, insert into the solution set. Finally, all of this is just outright a loop to iterate through. So this in itself is iterate through all numbers. Right? So that's iterating through all numbers to do all this. Oh, let's shrink this down as well. So sums to 0. Now, this is kind of an interesting one to refactor because notice how it's always 3 arguments. You could make it more generic, right? You could make it just an array of any amount of numbers and do it that way. As an example, if we just included this, now all of a sudden we can accept an array of any numbers and return if that sum is going to be equal to 0. So what we would do is we would write for int I is 0, I is less than number's length, I plus plus. We need to store our sum somewhere. Sum gets increased by numbers I. And then we return sum is equal to 0. So all this in itself checks if it sums to 0. And we can provide any amount of values now. Now obviously, for our intents and purposes, we're just trying to do 3 numbers. But you can see how you can make this more generic and make it into a more useful function overall. And you can do the same thing with all of these too. All these that require 3 values right now. Well, you don't have to do just 3 values. Why not supply them with numbers? So get sorted array values. This will provide the numbers into here. And then in here, you specify again another set of numbers. And finally, you're going to return an array containing all these numbers. It's already an array, so you just return it. Boom. And all of a sudden, you now have made it more flexible. And you barely had to do anything. That was such an easy change. In fact, it integrated it all better. It's just kind of magical like that. So now we're back up here. This all looks good. They're all into smaller, like, bite-sized functions. Now, all of this part can be a little confusing, but they can't really be shrunken down because they're just looping. You can make like I was thinking like in C style or C# style, you can provide like these ways to mask around the syntax, but it's like that's not really a good idea, honestly. So we iterate through all numbers, then we're gonna get a result, and we have to populate the results, right? So here we're converting the numbers into an array, or excuse me, into a list. So all of this, add to solution set, because that's all this is doing. Now, I understand that it is converting to a list here, so I mean, you can name this and say convert to list if you really want to, just to give that a little bit more of a name, but like you can kind of see it is converting it to a list there. So that's not as useful of a refactor, really. So you want to convert the list and you want to add to the list, so add list to results, like so. So add to solution set, adds the list to results, the list to results converts it to a list, and so on and so forth. So now we're down to this. Our code has gone from that mess to this, where we have our solution set, then we're gonna iterate through all of our numbers, initialize our results. In fact, we can move this up here so that our initializations are separate from our actual code. Iterate through all numbers. Then for every item, we can actually, let me think. I don't think this refactors because we don't actually have a, like you would need to provide it like an iterable there, but we don't need to worry about that. Iterate through all numbers, add them to the solution set, get the results. ThreeSum. That's just a nice demonstration of refactor, and of course the code still works. The code hasn't like blown up or anything. It just looks different to us now. So if I were to run it, runtime. Okay, it returned nothing. Maybe I was wrong. Maybe it didn't actually do anything. But what happened? Actually, I don't know. That's a good question. How did I break it? I mean, we could like debug it a little to see what's going on, but I mean, since I broke it, we might as well now, right? Let's see if at least the solution numbers pop up first, because that would indicate that at least we have that part down. Let's see, nothing's popped up, so I'm guessing the solution set isn't even there. Interesting. Let's see if it at least grabs all the... So my guess is that none of them sum to 0 anymore or something. So we're gonna first see what kind of sums we're getting, because I'm pretty sure the only reason nothing would appear in the first place is because if nothing summed to 0, right? So you can see here there are a whole bunch of sums coming out. So my question is now is, are there sums that actually equal 0 in here, which there might not be. So we're gonna see if any of them actually are 0 at all. Sums to 0. I will just provide all 3 of these, so we know which indices they are. So yeah, I don't think any of them sum to 0 anymore, which is odd because we are seeing the numbers in theory, right? So what changed is the question. Oh, I see what changed actually. We're sending in the indices when we need to actually send in the numbers themselves. So that's my bad for refactoring this a little weird. So we have to send in these. And then get sorted array values, it's the same deal, right? We're sending in numbers, we're not sending in indices. So when I refactored this, what I should have done was say nums numbers. You see where I went wrong there? When I refactored these, I didn't consider these were indices. So these aren't the numbers, we're gonna replace them with indices. So the computer didn't screw up, I screwed up. Of course. The humans always screw up. So you can see select number array values. Yes. So this is supposed to return the numbers themselves. And because it returns the numbers themselves, we don't actually need that second argument there. In fact, this I don't think is necessary at all. From what I can tell, it's just going to be a sorted array. So we're just sorting nums on the spot. Like so. And we can return nums. It doesn't hurt anything. When we return nums, we're going to be then doing stuff with it. Now we have to sum to 0. Nums indices. Or excuse me. Nums indices I. So, yeah, because I used indices here, it does get a little confusing. So we don't even need these. I think what I did, if I recall correctly, I refactored all this first, and then I refactored it like this part, and then only this or something. Something weird like that. That's why you want to go from inside out, not like jump around, because then all of a sudden things will be jumping around everywhere. So yeah, now this is going to add what values are what indices of what, whoops, do that. There we go. Let's see how that one fares. So this one took oh. It didn't split them into arrays of like 3. Surprisingly. Oh, I see. So that's why we had that other function. The other function was to create a new array. So I should have named that better. We'll call it like create new array, because we can't reference our current array, so we have to create a new one with only those sorted and return just those, not insert one giant array of stuff like we did here. That was not good. So if these 3 values sum to 0, right, then we're going to get the sort array values for those 3 indices. So the stuff I deleted earlier was required. This is one thing you have to be careful of with refactoring, because then all this mess happens and then you're not sure what's going on anymore. So we have to assemble an array with using those indices. That's essentially what we're doing. And that's why we had that one function originally, where all it did was return new int with those indices included. So we're actually going to have to make a new integer array. Of length indices.length, because we have to populate it with that. Array I will then be equal to indices I. Then we'll return our newly formed array, which will then get passed along up to create new array, which then we have to sort and return that array, which then we have to build a hash map key for, which we then see if it's a unique solution, which then we see insert into the solution set. Ooh. So originally, yes, we did have something like this, just didn't realize that that was what that it was serving. Like, I was looking at this like, huh, we make a little new array. What is the point? Okay, now these clearly don't add up to 0, so something went wrong there. Because if you look at it, yeah, these numbers clearly don't end up being 0. That's for sure. But my guess is these are the indices, because I'm looking here, create new array of indices, which is not what we want. We want the values of those indices, like so. And so by doing that, the indices, the values at those indices were made that set equal 0, not the indices themselves. Boom. So there we go. There's all of our values. Just to make sure that this still works, indeed, we can compare it to the tests that ran instead of here. Although this probably have to be local, not static. The only reason they were static functions was because of the main implementation. But if this were a standalone class, then we can do away with the static. Like so. And we can verify it still works with just their tests. It should fail when it gets further down the line, but So yeah, time limit exceeded once again. So that makes sense. Once again, got to the 311 of 313. So, and that's fine. Not a big deal. We just proved that it still works. So yeah, that was pretty cool. Again, I'm gonna try to do these every day to just kind of give some insight as to Java programming, what's possible, and then taking all that and turning it into useful practice.